We are going to start off with right angle trigonometry, which is like basic from geometry. So if you like geometry, yay. All right. You have 6 basic trig functions. They are all based off of 2. Sine and cosine are your 2 that they're all based off of. You'll notice they have the entire word written out. I just want to point out a few things here. Sine, the reason it's pronounced sine and not sin is because the actual word is sine, but because I don't want you to write sine and cosine and tangent and cosecant and secant and cotangent, we have abbreviations for them. Sine's abbreviated S-I-N, cosine, C-O-S, tangent, T-A-N, cosecant, C-S-C, secant is S-E-C, and cotangent, C-O-T. Okay? Now, in right angle trigonometry, you have this triangle. The triangle is based off of references. You have a couple things that are in reference to, or you have one thing in reference to the right angle. That is the hypotenuse. So your right angle is always opposite your hypotenuse. For the other 2 sides, opposite and adjacent, it depends on what angle you're talking about. All right, so it's very important that you know what angle you're talking about before you decide what is opposite and what is adjacent. In this case, they have the angle here where the theta, that's just a Greek letter, theta is. So the angle they have labeled here, theta, opposite is going to be the side that is opposite of that. So if you were to stand in this corner and walk across the triangle, that is your opposite side. The adjacent side is going to be one of the sides that makes up that angle. The angle is going to be made of the hypotenuse and another side. That side there is the adjacent. And so when you have these right angle trigonometry problems, you want to figure out what angle you're talking about, and then I always recommend you label it. All right, so then you want to label your opposite, your adjacent, and your hypotenuse. All right, and then we have your basic functions. Sine, that is your opposite side over your hypotenuse. Your cosine is your adjacent over your hypotenuse. All right, tangent, that is opposite over adjacent. Then you have the reciprocals of those functions. The reciprocal of sine is cosecant. All right, so we have the reciprocal of sine, which is cosecant. Since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. The reciprocal of cosine is secant. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. And then the reciprocal of tangent is cotangent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. All right? And hopefully you learned the little acronym. SOHCAHTOA. SOHCAHTOA. Right, so if you know the first 3, you can reciprocate them to get the second 3. Find the values. All right, they've already labeled theta for us. So since we have theta, we are going to label our triangle. The hypotenuse is easy. It is always opposite. I'm writing in highlighter. It's always opposite my right angle. If this is my angle, my opposite side is going to be the 8, and my adjacent side then is going to be the 15. All right? So if I want sine of theta, I'm going to say opposite over hypotenuse. Cosine of theta, I'm going to say adjacent over hypotenuse. And tangent of theta, I'm going to say opposite over adjacent. The other ones should be pretty easy. I'm just going to take that and flip it. All right, I want to point out a few things here. Your sine and cosine can never be bigger than 1. Why? Well, because they're over the hypotenuse. The hypotenuse is your longest side. So they should always be shorter than your longest side. So when you're looking at sine and cosine, as we move into this, you're going to come back to this knowledge of SOHCAHTOA. When we move to unit circle, we're going to come back to this knowledge of SOHCAHTOA, okay? And when you're calculating things, you want to come back to this knowledge of SOHCAHTOA. In that if you were to calculate the sine of something and get something larger than 1, or somehow think you're going to take something larger than 1 and come up with an angle using sine, you have a problem, okay? And so you want to come back to this basic knowledge always. That's why we start with SOHCAHTOA. So go ahead and try these, the 6 trig functions of A and B. Right, so 5/13, 12/13, and 5/12. And then your other 3 would be 13/5, 12/5, and 13/12. 12/5. Mm-hmm. Yep.
So for 1B, 21 would be hypotenuse.
All right, for this one, it says if the cosine of A is 2/5, find the exact value of the 5 remaining trig functions for the acute angle A. All right? So they're telling us, and in this case, you see the picture, but they're not giving us a picture, actually. I mean, they've just drawn it. They've just given us the information that the cosine of some angle A is 2/5. All right? So if I know they've given us the cosine, which two sides have they given us? They've given us adjacent and hypotenuse. So they've given us the adjacent side and they've given us the hypotenuse. All right. So without any other information, I can just sketch a triangle, right? I know if I am saying, okay, this is the angle I'm referencing and this is my right angle. I know my hypotenuse is 5 and my adjacent is 2, right? So if you need to sketch an angle, you can. If they want all 6 trig functions, I must solve for my opposite side to be able to give that, which I'm going to use the Pythagorean theorem to do so. Okay? All right? And so I would say, well, some side that I don't know plus the adjacent side equals the hypotenuse, right? And so I have this. So I know that a squared equals 21, so a is the square root of 21. And I can leave it at that because I'm going to use fractions. I can't simplify square root of 21, it's 3 and 7, right? So even with radical simplification, I can't simplify it. So we're going to leave it as square root of 21. And so I'm going to give the other 5. That means the sine of A is going to be my opposite side, which is what I solved for. Square root of 21 over 5. My tangent is going to be opposite over adjacent, right? Yes, over adjacent. Okay. If I were to find my other ones, right? And it's going to be a little out of order because they gave me cosine. Secant then is just going to be the flip of this. Cosecant is just going to be the flip of this. Do I want to leave it like that? If I'm asking, probably not. Yeah, I have a radical on the bottom, so we need to rationalize that. Multiply top and bottom by your radical. 5 square root of 21 over 21. All right. And then my cotangent is going to be the reciprocal of this guy. And again, we don't want to leave my radical on the bottom, so we're going to rationalize that guy as well. So from one trig function, I can calculate all 6 of them because of right angle trigonometry. All right. And as we get into other types of trig, there's actually some other tools of the trade you can use when given information. All right. But when we're talking about right angle trigonometry, they're all positive because we're talking about triangles. So we don't even have to worry about unit circle trigonometry right now. You just have to worry about opposite, adjacent, hypotenuse. All right, so go ahead and try guided practice 2. Given the information that they have here, solve for the other 5.
After that, you find the
Special types of triangles, also from geometry. If you remember in geometry, 30, 60, 90, and 45, 45, 90 had special cases.
Yes.
All right. And so you have for a 30, 60, 90, your shortest side, you could take that side and multiply by square root of 3, and you would get your longer side, or you could take that side and double it, and you would get your hypotenuse. All right. For a 45, 45, 90, the two sides were actually the same length, and your hypotenuse was that side times the square root of 2. This was a, 40 special triangles when we calculated them in geometry. As you move to right angle trigonometry, you see how this goes along with this. If I take a 30-degree angle then, which is this guy, the sine should be the opposite side. Actually, I'm going to relabel it because this is labeled based on, oh, nope, that's too much. Don't take that much off. That's based on my 60 degrees. So if I take my 30-degree angle here, right? So we're talking about the 30 column. I'm going to say this is opposite, this is adjacent, and of course this is hypotenuse. All right. So my sine then should be opposite over hypotenuse, x over 2x. Well, that reduces to 1/2, right? X over 2x. All right. The cosine should be square root of 3x over 2x, which reduces to square root of 3 over 2. The tangent should be the opposite x over the adjacent, which is going to give you 1 over the square root of 3, which when you rationalize this should be the square root of 3 over 3. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of my tangent. All right? Now, here's the thing. What you start seeing is that, and this is where your basis of right angle trigonometry comes from, is that no matter how big or how small the angle, those ratios will always hold true. All right? What do I mean by that? Well, if I were to, they've given you just a picture of 3 angles that you're very familiar with, 30, 45, and 60. What I will tell you is when we move to unit circle, these angles will become even more important. All right, because your unit circle is built off of these 3 angles. It's built off of these 3 angles. The entire unit circle is built off of these 3 angles. And actually, it's built off of 30 and 45 because your 60 is a factor, is a multiple rather of 30. And you'll notice, by the way, that from 30 to 60, they just flip-flop. So the sine of 30 is the cosine of 60. The cosine of 30 is the sine of 60. All right? What will always happen is, in a triangle, complementary angles, do you remember that term? They add up to 90. Complementary angles will always do this. So if you have an angle, and you know the sine of that angle, you actually also know the cosine of the complement. So complements will always do this process. 30 and 60 are complements of each other. You will always see the sine and cosine flip-flop between complements, okay? And so these 3 angles are your basis, and they're going to build it. And this is where some information you've already been familiar with, the special right triangles, helps you build this chart. Because these angles, you need to know bare minimum your sine, cosine, and tangent. Why do I say that? Well, you can get the cosecant. You can get the others based off of those. The cosecant, secant, and cotangent will be built off of those. And really, you can just know the sine and cosine, because when we move to the next section, then you can see that cotangent is just the combination of sine over cosine. All right? So this chart, you're going to need to know those. You're going to need to have to memorize those basics, at least the first 2. Probably better to go ahead and memorize the 3rd one as well, because it makes your life a little easier. A 30-degree angle, and wanting to be as close as possible. So let's say I have this guy. Let's say he's a 30-degree angle. Bear with me, okay? He's a 30-degree angle. That means that if I were to connect these right here, for that, or let's do it at a right angle because we're talking about right angle right now. If I were to draw this straight down, and here's my 30-degree angle, those ratios will hold true for that triangle. My opposite side compared to my hypotenuse will always be at a 1/2 ratio. Always. The opposite side will always be in a 1/2 ratio to my hypotenuse. All right? Which is the same if I were to draw a 30-degree angle that is like this. All right? My opposite side should still be in a 1/2 ratio, which means when I'm in a satellite and when I'm on the space station and moving a satellite from there to Earth at a 30-degree angle, the opposite side of that ginormous triangle will be in a 1/2 ratio to the hypotenuse. Always. Okay, it holds true no matter how big the triangle is. All right? Which, as you can imagine, is why this process was discovered to begin with. All right? So there's really 2 ways that you use this information. You use it by calculating a side, or you use it by calculating an angle. All right? And so calculating a side is easy, right? If you need to know what the sine is, well, we're just going to put opposite over hypotenuse. We're done, okay? So we're going to then back into the information to figure out angles, or use the angle to back into a side, whichever might be what we're doing. In this case, they've given us an angle, and they want us to solve for a side. And so when they've given us an angle, we're going to take it and we're going to label the triangle based on this angle that they gave us. They gave us this 42-degree angle, so we're going to label the triangle based on that angle. The 18 is obviously my hypotenuse because it is opposite my right angle. All right, if I'm looking at the 42, this side here would be the opposite, the one that's not labeled, and the x then would be the adjacent. So when I see this particular triangle, which two sides have something on them, either a variable or a number? Well, my adjacent side and my hypotenuse have something labeled, right? So which of my 6 trig functions deals with adjacent and hypotenuse? I have 2 of them, cosine or secant, right? Now, when I'm solving back into it, you're only going to use 3, sine, cosine, and tangent. Why? Look at your calculator. Those are the only ones on there, okay? So when you're doing inverse trig or when you're doing solving for a side, you're going to either use sine, cosine, or tangent. So in this case, adjacent and hypotenuse is my cosine, all right? So that means the cosine of this 42-degree angle, cosine of the 42-degree angle should equal my adjacent side over my hypotenuse. I am trying to solve for my x. How do I solve for x here?
Multiply 18 over.
Right, I have x divided by 18, so if I want to solve for it, I'm going to multiply both sides by 18. So if I take 18 times the cosine of 42 degrees, I should equal x. Okay, I want to point out here on your calculators, it is very, very important that you are in the right mode, all right? You will have 2 modes on your calculator. You will have radians and you will have degrees. We will use both in this chapter. For this particular one, this little symbol here means that we are using degrees, all right? So make sure you go into your mode of your calculator and check it always, always, all right? So when you do this, you should have gotten, rounding to 1 decimal place, you should have gotten 13.4. So go ahead and try those 2. A competitor in a triathlon is running along the course shown.
Why can't it be like
Determine the length in feet that the runner must cover to reach the finish line. So they have to run this particular course. They have given us the degree measure, right? They've given us the one measure here. And then they want us to find this, the distance from where they are to the finish line. All right. All right, so if I have this, I'm going to do exactly the same thing. So if they had, sometimes they do this and sometimes they don't give you a picture. On both of these, they did. Sometimes they don't, and you have to draw your own picture based on the description, which is what we're going to do at the end of this section. But based on this, here's my angle. That means this is opposite. That means this is hypotenuse. Which trig function am I going to use for opposite and hypotenuse? Sine of 63 equals the opposite 200 over the hypotenuse. Anytime what you are solving for is in the denominator position, means that your variable is going to equal the numerator divided by the trig function. That's how it's always going to work out if your x is in the denominator, okay? And so when you do that, you're going to get the answer of about 224.5 feet, all right?